On the first night of July in 2025, a telescope sitting on a quiet hillside in Chile caught something that should not have been there. A faint smudge of light drifting through the crowded star fields near the heart of the galaxy. Nothing about it looked urgent at first, just another moving dot in a sky full of them. But within hours the numbers came back, and the numbers were wrong. Not wrong like a mistake, wrong like a thing that does not belong. This object was not orbiting our sun. It was not born here. It had been falling through the dark between the stars for longer than the Earth has existed, longer than the sun has burned, and it was about to pass through our small corner of space exactly once, and then leave forever. Tonight, you're going to follow that object all the way through, where it came from, how old it really is, what it is made of, and why some of what it is made of has no business being there. Settle in, let your breathing slow. This is the story of the third visitor, and everything we learned in the brief window we had to look. Part 1. The smudge that should not have been there. The machine that found it has a name that sounds almost like a warning. The Asteroid Terrestrial Impact Last Alert System. People call it ATLAS for short. It is a small network of telescopes scattered around the planet, and its entire job is to watch the sky for things that might one day fall on us. Rocks on a collision course, quiet threats moving in the dark. Most nights it finds nothing of concern, just the ordinary traffic of the solar system, asteroids and comets following the same loops they have followed for billions of years. On this night, the telescope doing the watching was a single unit at a site called El Source, in the Rio Hurtado Valley of Chile, where the air is dry and the skies are some of the clearest on Earth. It takes the same kind of picture again and again, 4 times a night, sweeping across the heavens, comparing each frame to the last, looking for anything that moved. And on the 1st of July, something had moved. The object was near the orbit of Jupiter when they caught it, out past Mars, drifting through the asteroid belt at a distance of roughly 4 times the space between the Earth and the Sun. That is a long way out. Far enough that it should have been a slow, lazy thing, the way distant objects usually are. It was given a temporary name, the kind of placeholder astronomers assign before they know what they are looking at. A 11PL3Z, a string of letters and numbers that means nothing to anyone, a label for a stranger. And then the telescopes around the world turned toward it, because that is what happens when something new appears. They wanted to know its path. They wanted to know where it was going, and where it had been. Here is the thing about a star field near the centre of the galaxy. It is the worst possible place to try to track a faint moving object. The object was sliding across the dense band of the Milky Way, the part of the sky where the stars pile up so thickly they blur into a glowing river. Picture trying to follow a single firefly across a stadium where every seat is filled with a brighter light. That was the challenge. The background was a wall of stars, and the visitor was a dim grey ghost passing in front of them. The astronomers had to pick it out anyway, frame by frame, measuring exactly how far it shifted between one photograph and the next, because that shift, that tiny migration across the sky, was the key to everything. They measured it. They fed the measurements into the orbital calculators that humanity has spent decades perfecting, and the answer that came back changed the whole character of the night, because the path this object was on did not bend the way a normal path bends. Everything that belongs to the sun, every planet and moon and comet and stray rock, travels on a closed loop. It goes out, it comes back, it goes out again, held on its leash by gravity. Forever. The math of that leash is well understood. We can predict where a rock will be in 50 years, down to the width of a room. But when they ran the math on a 11PL3Z, the loop did not close. The path was open. It came in from the dark, it would swing past the sun once, and it would go right back out into the dark and never return. That single fact reframed everything. A closed loop means a local object, a member of the family, something that formed in the same swirling disk of gas and dust that made the planets 4.5 billion years ago. An open path means a stranger. It means the object was not made here. It was made somewhere else, around some other star, and at some point in the deep past it was thrown out of its home, flung into the emptiness between the stars, and it has been travelling ever since, falling, drifting, carrying whatever it was made of across distances so large that the human mind has no honest way to hold them. The day after the discovery, the body that keeps the official catalogue of small objects in the solar system made the announcement. The number that proved it was a shape measurement, a value that describes how stretched out an orbit is. For a perfect circle, that value is 0. For the long oval paths of ordinary comets, it creeps up toward 1 but never quite reaches it. Anything below 1 is bound to the Sun. Anything above 1 is not. This object came back with a value above 6, not just past the line, but far past it, further past it than anything we had ever measured. The orbit was so open it was barely an orbit at all. It was a straight shot through the neighbourhood, a single pass, a visitor who would knock once and then be gone. So they gave it a real name. They retired the placeholder and called it 3I Atlas. The 3 because it was the third of its kind we had ever found. The I for interstellar, the word that means it came from between the stars, and Atlas for the patient little telescope in Chile that caught it first. It also picked up a second designation in the comet catalogue, C2025-1, the bookkeeping label that ties it to the year we found it. But the name that matters is the first one, the third interstellar object, only the third in all of human history that we have ever caught in the act of passing through. And the strangest part, the part that would not become clear until later, is that this faint grey smudge near Jupiter was already the oldest thing any of us had ever looked at. Older than the rocks under your feet, older than the sun in the sky. It had been falling toward this moment for an amount of time that does not fit inside a human life, or a human civilization, or the entire span of life on Earth. It was just beginning to wake up, and we were just beginning to watch. Part 2. The path that refuses to close. Let us stay with that number a little longer, because it is the foundation everything else rests on, and it deserves to be understood slowly. The shape value for 3I Atlas came back at roughly 6.1. For most of human history we had never measured anything like it. The comets we know, the ones that return again and again across centuries, the famous ones with names, all of them carry a shape value just shy of 1. Halley, the comet that has been watched by human eyes for more than 2,000 years, comes back every 76 years on a long-stretched oval. It leaves, but it is always coming back, because the sun never lets go. Its leash is long, but it is real. A value of 6 is not a long leash. A value of 6 means there is no leash at all. To feel why that matters, think about throwing a ball. If you toss it gently, it arcs up and falls back into your hand. That is a bound orbit, a closed loop, the ball forever tied to the Earth's pull. Now imagine throwing it so hard that it never comes down, that it climbs and simply leaves, sailing off into space, never to return. There is a speed at which that happens, a threshold called escape velocity, the exact speed needed to break free of a gravitational grip forever. Everything bound to the sun moves slower than the local escape speed. 3I Atlas was moving faster, much faster. It had arrived already carrying more speed than the sun could ever take back, which can only mean one thing. It did not get that speed from the sun. It brought the speed with it, from wherever it began. The measurements settled near 58 kilometers per second for its true speed. The speed it carries through deep space far from any star's influence. That is its cruising speed, its natural pace through the dark. As it fell toward the sun and the sun's gravity pulled it inward, it sped up, the way anything speeds up when it falls, and near its closest approach it was moving at something closer to 68 kilometers per second. Put those numbers into terms a body can feel, and they become absurd. At discovery it was crossing space at around 220,000 kilometers per hour. Near the sun, well over 240,000. Fast enough to cross the entire width of our planet in less than 2 minutes. Fast enough that no rocket we have ever built could catch it from a standing start. It was never going to slow down for us. It was never going to circle back. It came in hot, it would round the sun, and it would leave just as fast as it arrived, carrying its speed back out into the night. This is the cruelty of an interstellar visitor, and also the wonder of it. We get one look. One. There is no second pass. No returning in our grandchildren's lifetimes. No chance to send a probe out to meet it on the next loop because there is no next loop. The window opens, the window closes, and the object is gone forever into a part of the sky we will never reach. Every photograph, every spectrum, every measurement had to be gathered inside that single narrow window, by telescopes scrambling to point themselves at a grey smudge that was already on its way out the door. And it had come from a very particular direction, trace its path backward, run the clock in reverse, and the line points toward the rich star clouds along the border of Sagittarius and Scutum, down near the bright, crowded heart of the Milky Way. That is where it appeared to be coming from, sweeping up out of the galactic plane and into our solar system on a steep angle, tilted almost completely opposite to the flat plane on which the planets ride. The technical word for that tilt put it past 175 degrees, which is another way of saying it was travelling backward relative to almost everything else, against the grain of the whole solar system, a salmon swimming up a river that flows the other way. Compare it to the two that came before, and the differences sharpen into focus. The first interstellar object we ever found, back in 2017, carried a shape value just above 1, barely past the threshold, a stranger that had only just been confirmed as a stranger. The second, found in 2019, was a little further past the line, but 3i Atlas blew past both of them. Its shape value was the most extreme of any object ever recorded passing through the solar system, the clearest signature yet of something that did not belong to us in any way. The first two were strangers who had wandered close to home. This one was a stranger from much farther away, moving faster, on a steeper path, carrying the deepest fingerprint of the interstellar dark. There is a quiet question buried in all of this that is worth sitting with. How does an object end up flung between the stars in the first place? The answer is that solar systems are violent places when they are young. When a star forms, it is surrounded by a vast disk of gas and dust, and out of that disk planets slowly gather themselves together. But not everything makes it into a planet. There are countless leftover pieces, icy chunks and rocky fragments, the rubble of construction, and the young planets, especially the big ones, are gravitational bullies. They fling things. A comet wanders too close to a giant planet, gets a tremendous slingshot kick, and is thrown clean out of its home system, exiled into the dark with no way back. This has almost certainly happened in our own solar system countless times, our own giant planets hurling our own icy fragments out into interstellar space, where they still drift today. 3i Atlas is the same kind of exile. Somewhere, around some other star, in some impossibly distant past, it was thrown away, and it has been falling outward ever since, through a darkness so complete and a silence so total that the journey defies imagining. Now hold that picture. An object the size of a small mountain, or perhaps a city, tumbling slowly through the absolute cold, lit by nothing but the faint distant glow of stars, no warmth, no sound, no destination. For a span of time we're about to try to measure, and the measurement is going to be staggering. It crossed the empty gulfs between star systems, it threaded its way through the galaxy, and by pure chance, out of all the directions it could have gone, and all the eras in which it could have arrived, it fell toward our small yellow sun at the exact moment in cosmic history when a species on the third planet had finally built telescopes good enough to notice. A few thousand years earlier, and no one would have seen it. A few thousand years later, the same. But it arrived now while we were watching, and the closer we looked, the older it turned out to be. Part 3. A home that may no longer exist. When astronomers traced the path of 3i Atlas backward, they did not just find a direction, they found a neighbourhood, and the neighbourhood it came from tells a story all its own. To understand it, you have to picture the shape of our galaxy honestly, not as the flat pinwheel of the famous paintings, but as the layered structure it actually is. The Milky Way has a thin, bright disk, a flat plate of stars where most of the action happens, where new stars are still being born out of clouds of gas, where our own sun lives, riding along in the calm, crowded mid-plane. But wrapped around that thin disk, above it and below it, is something older and quieter, a thicker, more diffuse layer of stars called the thick disk. And the stars of the thick disk are not like our sun. They are ancient. They formed in the early days of the galaxy, when everything was younger and wilder, and they have been orbiting ever since on paths that carry them high above and far below the bright central plane. The motion of 3i Atlas matched that older population. Its velocity through the galaxy, the way it was moving relative to the great river of stars, marked it as a member of the thick disk. It was not a child of the bright crowded midplane where we live. It was a child of the ancient halo above it, a wanderer from a part of the galaxy we had never before sampled up close. One of the astronomers studying it put the idea plainly. This was an object from a region of the Milky Way we had never seen before, never held in our hands, never broken down into light and red, and now one piece of it was falling through our solar system, close enough to study. Think about what that means for the star it came from. If 3I Atlas formed in the thick disk, then it formed around a star that is itself extraordinarily old, one of the early generation, born when the galaxy was young, and stars do not live forever. The brighter and more massive a star is, the faster it burns through its fuel and dies. Even modest stars eventually swell, shed their outer layers, and fade into dim cinders over billions of years. So the star that made 3I Atlas, the star whose disk of gas and dust gathered this icy fragment together and then flung it away, may not even exist anymore. It may have died long ago, collapsed or faded or scattered, its planets long since frozen or swallowed. The object passing through our solar system could be an orphan in the most complete sense, a survivor of a home that is gone, a piece of a vanished world circling a vanished sun, still carrying the chemistry of a place that no longer has an address. That is a strange grief to feel for a lump of ice and rock, but it is hard not to feel it. Everything you have ever known, every person and place and memory, exists inside a sliver of time so thin that this object would not even register it. While 3I Atlas was crossing the dark, whole civilizations rose and fell on Earth in what would have been, to the comet, a single, silent instant, and its own origin, its own beginning, lies so far back that the star it was born from may have lived its entire life, and died while the comet was still only partway through its journey to us. There is a second strangeness in the direction it came from. The comet appeared to be falling in from the region toward the galactic centre, from the dense, crowded star clouds near the heart of the Milky Way, and it was moving on a steep, almost vertical path relative to the flat plane of the planets. Our Sun travels on a fairly gentle, fairly circular orbit around the galaxy, staying close to the midplane, going around and around in the calm lane. The path of 3I Atlas, projected across the whole galaxy, was wild by comparison. It swung far out into the thick disk, high above and far below the plane, a long looping galactic orbit that took it through regions our Sun has never visited. The two paths, the Sun's and the comet's, crossed for one brief moment in the vast emptiness, and that crossing is the only reason we ever met. A coincidence of geometry, billions of years in the making, two travellers on wildly different routes happening to pass within sight of each other for a single afternoon of cosmic time, and when it leaves, it will not go back the way it came. Once it rounds the Sun and the Sun's gravity bends its path, the comet will be flung off in a new direction entirely, outward toward the constellation of Gemini, in the general direction of a star called Zeta Geminorum. Not that it will go to that star. The star simply happens to lie along the line of its departure, a distant signpost marking the way out. From our point of view on Earth, that is the direction it will shrink into and vanish, a fading grey point sliding toward Gemini and then gone, swallowed by the same dark it came from, on its way to somewhere none of us will ever follow. It is worth pausing on the sheer scale of the silence this object has known. Between the stars there is almost nothing, a few stray atoms per cubic centimetre, less than the best vacuum we can create in a laboratory on Earth. No air, no light except the faint scattered glow of distant suns. Temperatures hovering just a few degrees above the coldest possible cold, the temperature of empty space itself. For the entire length of its journey, 3I Atlas knew only that. No warmth touched it. No nearby star lit its surface. It simply fell, tumbling slowly, frozen solid, a sealed time capsule preserving whatever it was made of at the moment it left home, kept in a deep freeze more perfect than any we could build. That is what makes these visitors so precious to the people who study them. A comet from our own solar system is interesting, but it is family. We already know roughly what it is made of because it formed from the same material as everything else around us. An interstellar object is different. It is a sample from another star system, delivered to our doorstep at no cost, carrying the recipe of a completely different world. Read its chemistry, and you are reading the chemistry of a place you could never reach, a protoplanetary disk that spun around a foreign sun billions of years ago. You are tasting another solar system, and in the case of 3I Atlas, you may be tasting one of the oldest solar systems that ever formed in the entire galaxy. So the natural next question, the one that everyone wanted answered the moment they realized where this thing came from, was simple and enormous at the same time. Exactly how old is it? And the answers that came back were not measured in millions of years, or even in the 4.5 billion years that mark the age of everything in our own neighbourhood. The answers reached back further than the Sun, further than the Earth, back toward the youth of the galaxy itself. That is where we go next. Part 4. Older than the Sun. Within days of the discovery, a team of astronomers working between New Zealand and the University of Oxford ran 3I Atlas through a model they had built for exactly this kind of question. The model works by comparing the comet's motion through the galaxy to the motions of the different populations of stars, the young ones in the thin disk, the old ones in the thick disk, and matching it to where it most likely belongs. When they fed in the numbers, the answer came back larger than almost anyone expected. The model suggested 3I Atlas was very likely more than 7 billion years old. And to understand how staggering that figure is, you only need one comparison. Our entire solar system, the Sun and every planet and every comet that belongs to it, is about 4.5 billion years old. This visitor was older than all of it, older than the Sun, older than the Earth, by a margin of more than 2 billion years. Let that settle for a moment, because it is the kind of fact that is easy to read and almost impossible to truly absorb. When this object formed, the Sun did not exist. There was no Earth. There was no solar system at all, not even the cloud of gas that would one day collapse to make it. The atoms that would become your body were scattered across the galaxy, unassembled, waiting. And already, around some ancient star in the thick disk of the Milky Way, this comet had gathered itself together out of ice and dust, and had perhaps already been thrown out into the dark. It had been travelling for billions of years before the ground you stand on had even begun to form. One of the researchers put it in a way that captured the strangeness perfectly. There is, he said, roughly a 2 in 3 chance that this comet is older than the solar system, and that it has been drifting through interstellar space ever since. Drifting through interstellar space ever since, sit with that phrase. Ever since means for billions of years. It means that across the entire history of life on Earth, from the first single cells in the ancient oceans, through every dinosaur, every ice age, every human being who has ever lived and loved and looked up at the night sky, this object was already in flight, already falling toward us, already old beyond reckoning. It witnessed nothing, because there was nothing to witness in the empty dark. It simply endured, frozen and patient, while everything you have ever heard of came into being and passed away. And 7 billion years may only be the beginning. As more telescopes turned toward 3I Atlas and studied its composition in detail, a separate line of research pushed the estimate even further back. One study, examining what the object was made of and how its chemistry compared to models of ancient star systems, concluded that the comet may have formed somewhere between 10 and 12 billion years ago. That number does not just predate the solar system, it approaches the age of the Milky Way galaxy itself. It edges toward the age of the universe. The cosmos as a whole is a little under 14 billion years old. A comet that formed 10 to 12 billion years ago would have come together when the galaxy was still young, when the first generations of stars were still forging the heavy elements that everything is made of, when the universe itself was barely a third of its current age. Taken together, the various estimates spread across a wide range, from around 7 billion years on the cautious end to as much as 14 billion on the boldest. But every single estimate agreed on the headline. This object is ancient, quite possibly the oldest thing human beings have ever observed up close. The astronomers gave that ancient era a name. They call it cosmic noon. It refers to the period roughly 9 to 13 billion years ago, when the universe was forming stars at its most furious rate, when galaxies blazed with new suns igniting one after another, a peak of creation that has never been matched since. The rate of star birth in the universe has been slowly declining for billions of years now. We live in the long quiet afternoon of cosmic history, the fires burning lower, fewer new stars lighting up each year. But 3I Atlas may be a relic of the high noon of creation, a fragment left over from the most fertile era the cosmos has ever known, a piece of the building material from when the galaxy was assembling itself in a frenzy of light. To hold a sample from that age, to actually study a physical object that formed during cosmic noon, is something no one had ever done before. We had seen the light of that era, the the ancient glow of distant galaxies reaching us across billions of years. We had never had a piece of it pass through our own backyard. How can scientists be so confident about an age that large when they have only watched the object for a matter of months? The answer is that they are not certain, and they are careful to say so. The age is a model-based estimate, built on the comet's motion and its chemistry, and our best understanding of how the galaxy's stellar populations are distributed. It is not a birth certificate. There are reasonable scientists who urge caution, who point out that the indicators are suggestive rather than conclusive, that an object can carry the motion of the thick disk without our being able to pin its exact age to within 1 billion years. This is the honest texture of real science, the part that the loudest headlines tend to flatten out. The strong claim is that 3I Atlas is very probably ancient, probably older than the Sun, possibly far older. The honest caveat is that the precise number remains uncertain, and that the comet itself, as it warms and changes near the Sun, may yet reveal details that sharpen or revise the estimate. Both things are true at once. It is almost certainly old beyond anything we have measured, and we do not yet know exactly how old. But even the cautious version of the story is overwhelming. Even the modest end of the range, 7 billion years, describes an object that watched the Sun and Earth come into existence from the outside, an object that was already old when our world was nothing but a hot disk of debris. There is no human frame for that kind of age. We measure our lives in decades, our histories in centuries, our species in a few 100,000 years, and even the dinosaurs, those ancient giants that ruled the Earth, lived only a few tens of millions of years ago, which is the day before yesterday compared to this. The comet predates them by billions of years. It predates the planet they walked on. It predates the star they lived under. And here is the quiet, beautiful irony at the centre of it all. This thing, older than the Sun, older than the Earth, possibly nearly as old as the galaxy itself, was found by a creature whose entire civilization is a flicker, a species that has only had telescopes for 4 centuries and only had the math to recognize an interstellar visitor for a handful of decades. The oldest object we have ever seen was caught by one of the youngest things in the story, in the narrowest possible window, by pure chance. If the comet had arrived even slightly earlier in human history, we would have missed it entirely, blind to its passing. It would have come and gone unseen, as surely thousands of others have over the long ages, unwitnessed visitors slipping through an empty solar system. But this one arrived now. And now we could finally ask the next question, the one that turned the story from a tale of age into a genuine mystery. Not just how old it is, or where it came from, but what, exactly, it is made of. Because when the telescopes finally read its chemistry, the recipe did not look like any comet we had ever seen. Part 5. The comet that was made backward. To read what a comet is made of, you do not need to land on it or scoop up a sample. You only need its light. When sunlight strikes the cloud of gas and dust around a comet, and when the comet's own materials warm up and glow, the light that comes off carries a hidden code. Each kind of molecule, each element, absorbs and emits light at its own specific colours, a fingerprint as unique as a barcode. Spread that light out into a spectrum, the way a prism spreads sunlight into a rainbow, and the dark and bright lines that appear tell you exactly what is present. Carbon, oxygen, water, nickel, every ingredient announces itself in the pattern of the light. So as 3I Atlas warmed on its approach toward the Sun and began to release gas, the great telescopes of Earth and space turned to catch that light and decode it. A comet is supposed to be, in the old familiar phrase, a dirty snowball, mostly water ice, frozen hard as rock in the deep cold, mixed with dust and a scattering of other frozen gases. When a normal comet approaches the Sun, the water ice is the first thing to wake up. It warms, it turns directly from solid to vapour, and that escaping water vapour is what builds the glowing cloud around the comet and streams off into the long, bright tail. Water is the headline ingredient. It is what makes a comet, in the way we have always understood them. Every comet from our own solar system follows this rule. Water first, water most, water always dominant. 3I Atlas broke the rule completely. When the space telescopes read its spectrum, the dominant ingredient was not water at all. It was carbon dioxide. The same gas you exhale, the same gas that fizzes in a soda, frozen into the body of the comet and now pouring off it as it warmed, and it was not a small majority. The cloud of gas around 3I Atlas turned out to be overwhelmingly carbon dioxide, with only a tiny fraction of water. The measurements put the carbon dioxide at something like 87% of the gas by mass, with carbon monoxide making up most of the rest, and water reduced to a mere sliver, around 4 or 5%. Some instruments measured the carbon dioxide compared to the water, and found a ratio of roughly 8:1, one of the highest such ratios ever recorded in any comet anywhere. This was not a dirty snowball. This was something else. A frozen world built around a different chemistry entirely, a comet that had its priorities reversed. Imagine you had only ever seen one kind of fruit your whole life, and you knew exactly what was inside it, sweet flesh around a small pit. And then one day someone hands you something that looks like that fruit on the outside, but when you open it, the proportions are inverted. The pit is enormous and the flesh is almost gone. You would stop and stare. You would know immediately that this thing grew somewhere very different, under very different conditions, following very different rules. That is what the spectrum of 3I Atlas was like to the astronomers reading it. A familiar shape with an unfamiliar inside, a comet whose recipe had been written by another world. Why would a comet end up so rich in carbon dioxide and so poor in water? The leading explanation reaches right back to where the object was born, and to the deep cold it endured for billions of years. Different ices freeze and thaw at different temperatures. Water ice is relatively hardy. Carbon dioxide ice, the kind we call dry ice on Earth, freezes and vaporizes at much colder temperatures. So if a comet formed in an extremely cold region of its home system, far out where even carbon dioxide could freeze solid and stay frozen, it might lock away a great deal of it. And then there is the matter of time. For billions of years, 3I Atlas drifted through interstellar space, bathed not in warmth, but in a constant rain of cosmic radiation, high-energy particles streaming through the galaxy and striking its surface. Over that immense span, the radiation may have slowly cooked and altered the outer layers of the comet, driving off some materials and transforming others, building up a kind of weathered shell rich in carbon dioxide ice. When the sun finally warmed it, that shell began to vent, and what we saw venting was the chemistry of a billion-year deep freeze, not the fresh recipe of a young comet. One of the astronomers described the moment with a kind of awe that is rare in careful scientific language. The carbon dioxide to water ratio, she noted, was among the very highest ever seen in any comet. Another said simply that they had cracked open the door to a whole new world of chemistry that they had never had access to before. That is not the language of routine observation. That is the language of people who knew they were looking at something genuinely new, a sample from a place and an era that no instrument had ever before been able to taste. Every comet they had ever studied was a relative, made of the same stuff as the Earth and the Sun. This one was a true foreigner, and its foreignness was written in the very molecules pouring off its surface. There were other ingredients in the mix as well, the ordinary alphabet of comet chemistry, but in unusual amounts. Carbon monoxide, a scattering of other carbon and oxygen compounds, and later, as it rounded the Sun and was studied again, signs of methanol, a simple alcohol, present in quantities that surprised the people measuring it. Each of these was a clue, a single letter in a word we are still trying to spell, a hint about the conditions in the ancient disk where this object first took shape. A cold place, a strange place, a place where carbon dioxide ruled and water was scarce, around a star that may no longer shine, in an era of the galaxy long since past. But of all the ingredients the telescopes found, one stood out far more than the rest. One ingredient that did not fit any of the easy explanations, that did not match the pattern of any comet we had ever studied, and that, when a certain well-known scientist examined it, led him to say a word that most of his colleagues are extremely careful never to say out loud. The comet was giving off pure nickel, a heavy metal streaming off this ancient object in a way that, here on Earth, we only ever see in one very specific and very artificial place. And that single anomaly, more than the age, more than the strange chemistry, is what turned the quiet study of an old comet into a debate that spilled out of the journals and into the wider world. That is where we turn next. Part 6. The metal that should not be there. Nickel itself is not strange to find around a comet. Comets contain metals, locked in their dust and rock, and when they warm up near the Sun, those metals can sometimes be detected glowing in the gas. The strange thing about 3I Atlas was not that it had nickel. The strange thing was what came with the nickel, or rather what did not. Because in every other comet we have ever measured, when nickel shows up, iron shows up alongside it. The two metals travel together. They are forged together in the hearts of dying stars scattered together across space, and folded together into the bodies of comets and asteroids and planets. Find nickel in a comet, and you will find iron in roughly the proportions you expect. They are partners. They are almost always found hand in hand. 3I Atlas gave off nickel with almost no iron at all. The telescope saw the bright fingerprint of nickel gas glowing in its coma, strong and clear, and they looked for the matching fingerprint of iron, and it was faint to the point of absence. Nickel without its lifelong partner, a metal showing up alone, separated from the element it is almost never separated from. To the people studying it, this was deeply unusual. There is no standard fixed ratio of these metals in comets. They do vary, but a comet pouring out nickel while withholding iron, far from the Sun, was a pattern that did not match anything in the catalogue. Then came the detail that made the story leap from the scientific journals into headlines around the world. There is, though, a place where we routinely see nickel cleanly separated from iron. We see it here, on Earth, in factories. There is an industrial process used to refine and purify nickel that works by combining it with carbon monoxide to form a compound called nickel tetracarbonyl, a volatile poisonous gas that can then be broken back down to deposit pure nickel. It is a piece of human chemical engineering, a way of pulling clean nickel out of raw ore, and one of its signatures is exactly this: nickel moving around freely while iron stays behind. A Harvard astrophysicist named Avi Loeb, a scientist well known for raising provocative possibilities about interstellar objects, looked at the nickel signature of 3I Atlas and pointed this out in the bluntest possible terms. There is, he noted, essentially only one place this particular chemistry was previously known to occur, and that place is industrially produced nickel alloys. He was careful in his exact wording, but the implication hung in the air, heavy and unmistakable. The kind of chemistry we see here is the kind we make in factories. So why is an interstellar object producing it? It is easy to see why that framing spread so fast. It taps into something deep, a question humanity has asked for as long as we have looked up. Are we alone? And here was a genuinely ancient, genuinely strange object from another star, doing something that, on Earth, only happens inside human industry. The internet did what the internet does. The word that scientists are trained to avoid until every other explanation is exhausted started appearing everywhere. Alien, manufactured, a probe, a ship, a thing that was made. So let us slow down, and let us be honest, because the honest version of this story is more interesting than the sensational one, not less. The nickel anomaly is real. The measurement is real. The strangeness is real. What is not established, what the loud version leaves out, is that the same industrial chemical pathway can also happen naturally, without any factory at all. The process that builds nickel tetracarbonyl requires nickel and carbon monoxide, and 3I Atlas happens to be unusually rich in carbon monoxide. Put nickel-bearing dust grains in an environment flooded with carbon monoxide far from the sun, and the same chemistry that we exploit in industry can occur on its own, slowly, in the cold space around the comet's nucleus. The compound forms naturally, then breaks apart when struck by ultraviolet light, releasing the pure nickel we detect, the very thing that makes 3I Atlas look manufactured. Its strange separation of nickel from iron may be a direct and natural consequence of its strange but entirely physical chemistry, the carbon dioxide and carbon monoxide rich recipe we already knew it had. The scientists who actually published the nickel observations said exactly this. They proposed that the process was happening naturally near the comet's nucleus, a piece of unusual but understandable chemistry, not a piece of technology. And other astronomers, examining the same data, pushed back firmly against the sensational reading. One pointed out that while the nickel signal is genuinely an extreme value, a real outlier, it is also entirely consistent with what we know about how comets behave. We were simply seeing nickel at a much greater distance from the Sun than we usually look for it, under conditions we'd rarely studied, and the chemistry that explains it is, in his words, pretty standard once you account for those conditions. There is interesting chemistry going on, he said. but nothing that suggests the object is plated in metal or built by hands. As it heated up closer to the Sun, he expected its behavior to fall more in line with the comets we know. Weird, yes. Unheard of, no. This is the part of the story that rarely makes the headlines, and it is the part that matters most. A strange measurement is not the same as a confirmed mystery, and a confirmed mystery is not the same as evidence of design. Real science lives in the gap between those things, and it moves slowly and carefully through that gap, ruling out the ordinary explanations one by one before ever reaching for the extraordinary. The nickel without iron is a genuine puzzle that deserves genuine attention. It is also, most likely, a natural puzzle, a quirk of an ancient comet with an unusual chemical makeup venting metal in an environment we had simply never observed before. Both of those statements can be true. The honest scientist holds them together. The honest answer is that we found something we did not fully understand, that the most likely explanation is natural and not artificial, and that the finding is fascinating precisely because it is teaching us new chemistry, not because it is whispering of spaceships. And there is a quiet wisdom in why scientists are so reluctant to reach for the word alien, even when an object seems to invite it. We have been here before. The first interstellar object, the one found in 2017, was strange in its own ways, oddly shaped and behaving in ways that took years to fully explain, and the same provocative voice raised the same provocative possibility about it too. In the end, careful study found natural explanations for its oddities. The history of astronomy is full of strange signals that looked, for a moment, like they might be something more, and that turned out, on patient examination, to be the universe simply being stranger and richer than we expected. That does not mean the search for genuine signs of other intelligence is foolish. It means the bar is high, deliberately and correctly high, and that an unusual ratio of metals in a comet's coma does not come anywhere close to clearing it. But the nickel was not the only thing about 3I Atlas that pointed in the wrong direction. There was also, quite literally, a part of it that pointed the wrong way, because as the telescopes watched, this comet did something that comets are not supposed to do. It grew a tail aimed at the Sun. Part 7. The tail that pointed the wrong way. Everyone knows what a comet looks like, or thinks they do. A bright head and a long glowing tail streaming out behind it across the sky. And almost everyone assumes the tail trails behind the comet, the way a scarf trails behind a runner, blown back by the motion of the comet through space. That assumption is wrong, and the truth is far more elegant. A comet's tail does not point away from the direction it is travelling. It points away from the Sun, always. No matter which way the comet is moving, no matter whether it is racing toward the Sun or coasting away from it, the tail streams outward, directly opposite the Sun, like a windsock showing the direction of an invisible gale. The reason is that the tail is not made of leftover motion. It is made of material being pushed. The Sun pours out a constant stream of light and particles, a pressure that flows outward in all directions, and that pressure shoves the loose gas and fine dust of the comet's coma away from the Sun. Sunlight itself, gentle as it feels on your skin, carries a real physical push, and over the vast surface area of a comet's dust cloud, that push is enough to sculpt the tail. So a comet approaching the Sun has its tail blown out in front of it. A comet leaving the Sun has its tail trailing behind. The tail is a shadow of the solar wind, a banner showing which way the Sun is shoving. This is one of the most reliable rules in all of comet science. The tail points away from the Sun. 3I Atlas, in some of the images taken of it, appear to have a feature pointing the other way. A jet, a spike of material, aimed not away from the Sun but toward it. Astronomers have a name for this rare phenomenon. They call it an anti-tail. And while it sounds, on first hearing, like a violation of physics, like a thing being pushed in the wrong direction by an impossible force, the real explanation is subtler and has been seen before in ordinary comets. An anti-tail is usually a trick of perspective and particle size. The heavy dust grains, the larger and more sluggish ones, do not get blown away easily by sunlight. They linger near the comet, spread out along its orbit, and when the Earth passes through just the right viewing angle, that flat sheet of heavier dust can appear, from our line of sight, to stick out toward the Sun. It is, in many cases, an illusion of geometry, a real feature of the comet seen from an angle that makes it look impossible. But knowing the likely explanation did not make 3I Atlas any less unsettling to look at. Here was an object already strange in every other way, ancient beyond reckoning, chemically reversed, venting metal without its partner, and now it appeared to be growing a spike aimed back at the very star it was falling toward. Each anomaly on its own had a reasonable explanation. The antitail was probably a perspective effect. The nickel was probably natural chemistry. The carbon dioxide was probably a billion-year deep freeze. But the anomalies kept stacking up one after another, and the human mind is built to notice when the strange things start to pile in the same place. A single oddity is a curiosity. A whole list of oddities, all in one object, starts to feel like a message, even when each item on the list, examined alone, dissolves into ordinary physics. There was another measurement, less famous but just as strange to the specialists, that deepened the sense of an object that did not behave like its cousins. When astronomers studied the light reflecting off the comet's dust, they measured a property called polarization, which describes the way light waves are oriented after they bounce off particles. Polarization is sensitive to the size, shape, and composition of the dust grains, and so it serves as another fingerprint, another way of reading what a comet is made of and how its dust is structured. The polarization signature of 3E Atlas came back unlike anything previously recorded. It showed an unusually deep negative dip at a particular viewing angle, a feature the researchers described as unprecedented among the comets and asteroids of our own solar system. Once again, the object had given a measurement that sat at the very edge of, or just beyond, the range of everything familiar. Not impossible, not supernatural, just consistently, relentlessly extreme, an outlier in every category we measured. This is the texture of 3I Atlas that is hard to convey in a single headline. It is not that any one of its features screams impossibility. It is that nearly every feature, when measured, came back at the far edge of normal or slightly past it. The most extreme orbit ever recorded, among the highest carbon dioxide ratios ever seen, a nickel anomaly only otherwise known from industry, an antitail, an unprecedented polarization signature, cometary activity at distances where comets are usually still asleep. Take any one of these and a calm astronomer can explain it. Take all of them together, and even a calm astronomer has to admit that this is, by any measure, one of the strangest objects ever to pass through the solar system, a genuine outlier across nearly every dimension we know how to measure. And remember why all of that strangeness should be expected, in a way, rather than feared. This is a sample from another star system, formed in an era and a place utterly unlike our own, frozen and weathered for billions of years in the deep dark. Of course it is strange. Of course its chemistry is reversed, and its dust is unusual, and its metals come unpaired. It would be far more surprising, far more suspicious even, if a thing born around an ancient foreign sun, baked by cosmic rays for longer than the Earth has existed, turned out to look exactly like the comfortable comets of home. The strangeness is not evidence that something is wrong. The strangeness is the entire point. It is the reason these visitors are so precious. We are not looking at a familiar thing behaving oddly. We are looking, for only the third time in human history, at a genuinely foreign thing behaving exactly as a foreign thing should, in ways we are only beginning to learn how to read. Still, the anomalies, and the one loud voice willing to name the unnameable, had done their work in the wider world. By the time 3I Atlas approached its closest pass by the Sun, it was no longer just a quiet object in the astronomy journals. It had become a phenomenon, a name people knew, a subject of speculation in every corner of the internet, a screen onto which both careful scientists and hopeful dreamers projected their questions about whether we are alone. So before we follow it around the Sun and watch what happened next, it is worth pausing on that debate itself, on the man who said the word, on why he said it, and on what the rest of his field thought of him for saying it. Part 8. The Man Who Said the Word. There is a scientist at Harvard named Avi Loeb who has built a strange and prominent place for himself in modern astronomy. He is, by any measure, a serious physicist, with decades of real work behind him on black holes and the early universe and the search for life beyond Earth. But he is best known to the public for something else, for his willingness to take seriously a possibility that most of his colleagues consider almost taboo. When an unusual object appears, Loeb is the one who asks, out loud and in public, whether it might be technology, whether it might be made by another intelligence. He did it with the first interstellar object back in 2017, writing a whole book arguing that its oddities might be best explained as an artificial craft, perhaps a light sail built by some distant civilization. And when 3i Atlas arrived, with its growing list of anomalies, Loeb was once again the one asking the question no one else would. It is easy to dismiss this, and many of his colleagues do, but it is worth understanding why he does it, because his reasoning is not as foolish as the loudest critics suggest, nor as sound as his most fervent supporters believe. Loeb's core argument is about attention and humility. He points out that for most of history, we assumed we were the centre of everything, and we were wrong every time. The Earth is not the centre of the solar system, the Sun is not the centre of the galaxy. We are not the only planet, and almost certainly not the only place where the chemistry of life could arise. Given all that, he argues, it is a kind of arrogance to assume we must also be the only intelligence, and to refuse even to check. When a strange object appears, he says, we should at least consider the full range of explanations, including the possibility that it was made, rather than ruling that possibility out before we have looked. Keep an open mind, gather the data. Do not flinch from the question simply because it is uncomfortable. That much is hard to argue with. The trouble is where the open mind leads. Loeb has a pattern of emphasizing the anomalous, of highlighting every measurement that does not fit, of framing the strangeness of an object in language that invites the extraordinary conclusion even when he stops short of stating it outright. With 3i Atlas, he wrote extensively about the nickel without iron, about the carbon dioxide-rich coma, about the size estimates and the activity at great distance, always noting how unusual each finding was, always reminding his readers that some of these signatures, on Earth, are associated with manufacturing. He rarely said flatly that it was a spacecraft. He did not need to. The accumulation of emphasized anomalies did the work, and his audience, hungry for the answer they wanted, supplied the conclusion themselves. The rest of his field reacted with a mixture of irritation, patience, and concern. The irritation is obvious. Most astronomers feel that Loeb cries wolf, that he reaches for the alien explanation too quickly and too publicly, that he generates headlines that drown out the careful, unglamorous work of actually figuring out what these objects are. Every time he raises the possibility of technology, dozens of other scientists have to spend their time explaining, patiently, why the natural explanation fits the data better. The concern runs deeper. There is a worry that this kind of speculation, amplified across the internet, erodes public trust in science, teaches people to expect a cosmic revelation around every corner, and sets up a cycle of hype and disappointment that leaves everyone more cynical in the end. When the alien probe turns out once again to be an unusual but natural comet, some of the public does not hear the careful correction. They only remember the exciting claim, and the quieter truth never quite catches up. And yet there is a case for keeping a voice like his in the conversation, even among those who think he is usually wrong. Science advances by testing ideas, and an idea cannot be tested if no one is willing to propose it. By forcing the question, by insisting that the artificial hypothesis be considered and then ruled out with real evidence, rather than ignored out of embarrassment, Loeb arguably makes the eventual natural explanation stronger, not weaker. When astronomers carefully demonstrate that the nickel can form naturally, that the antitail is a perspective effect, that the orbit, however extreme, is exactly what we would expect from a thick disk wanderer, they are not just dismissing him. They are doing the work of elimination that turns a mystery into knowledge. The provocateur and the careful skeptic in the end need each other. One asks the wild question, the other does the patient work of answering it. The friction between them, uncomfortable as it is part of how the field moves forward. So what is the honest verdict on 3i Atlas? It is this. There is no credible evidence that it is anything other than a natural comet, an extraordinarily ancient one, an unusually chemically strange one, an outlier in nearly every measurement, but a comet. Everything observed about it, the nickel, the carbon dioxide, the antitail, the strange polarization, the activity far from the sun, has a natural explanation that fits the data, and in most cases fits it well. The overwhelming consensus of the astronomers who studied it, including the ones who actually gathered the data Loeb wrote about, is that it is a remarkable but entirely natural object, a frozen relic from another star system, behaving as such a relic should. The alien hypothesis was raised, considered, and found unnecessary. Not impossible to imagine, but unnecessary to explain anything we actually saw. There is something almost reassuring in that, if you let yourself feel it. The universe did not need to send us a manufactured probe to be astonishing. A plain comet made of ice and dust and metal turned out to be older than the Sun, born around a star that may no longer exist, carrying the chemistry of an era closer to the birth of the galaxy than to the birth of the Earth. That is not a letdown compared to the alien story. That is a wonder of a deeper and more durable kind, because it is true and because the truth of it does not depend on the universe performing for us. We did not find a message in a bottle. We found something better. We found a genuine piece of the deep past delivered by physics alone, asking nothing of us but that we look closely and learn to read what was always there. And look closely we did, with everything we had, right up until the moment the object slipped behind the Sun and out of our sight. Because as 3I Atlas approached the point of its closest approach, it was about to vanish from view at the very moment it became most interesting. Hidden in the glare of the star it had travelled billions of years and trillions of miles to meet. What happened during that hidden pass, and what we managed to see anyway by enlisting an entire fleet of robotic eyes scattered across the solar system, is the next turn in the story. Part 9. The Pass Behind the Sun. The closest approach came at the end of October in 2025, on the 29th day of the month. That moment when an object swings nearest to the Sun is called perihelion, and for 3I Atlas it happened at a distance of about 1 1/3 times the space between the Earth and the Sun. In human terms, around 126 million miles from the Sun's surface, comfortably outside the orbit of Earth, never anywhere near close enough to pose any threat to us. At its nearest to our own planet, it stayed more than 150 million miles away, well over 100 times the distance to the Moon. There was never any danger. The name of the telescope that found it carries the word alert, and that frightened some people into imagining a collision. But the truth is that 3I Atlas was only ever a passing visitor, threading through the outer parts of the inner solar system on a path that kept it safely distant from everything that mattered to us. But here was the frustration. At the exact moment of perihelion, when the comet was warmest, most active, pouring off the most gas and revealing the most about itself, it was on the far side of the Sun as seen from Earth, hidden, lost in the glare. The one telescope that mattered most, the network of human eyes on the ground and in orbit around our own planet, could not see it at the peak of its performance. Imagine training for years to witness a single event, and then having the most important minute of it happen behind a wall just out of sight with no way to lean around and look. That was the situation. The most ancient, most studied, most argued over object of the year was about to do its most dramatic thing, and from Earth, we were blind to it. So the astronomers did something clever. They did not rely on Earth alone. Over the past decades, humanity has quietly scattered robotic spacecraft all across the solar system. Probes sent to study the Sun, to orbit other planets, to map the sky in wavelengths our eyes cannot see. Most of them were built for entirely different purposes: to watch Mars, to study the solar wind, to hunt for distant galaxies. But a spacecraft is just a telescope that happens to be somewhere other than Earth, and some of those somewheres had a much better view of 3I Atlas than we did. So one by one, mission teams turned their instruments away from their usual targets and pointed them at the visitor. An entire improvised fleet, a network of eyes spread across millions of miles of space, all swinging toward the same ancient grey traveller. A spacecraft orbiting Mars, built to study that planet's thin atmosphere, captured the comet as it passed through the inner solar system, imaging the glowing halo of gas and dust around its nucleus from a vantage point far closer than Earth. The great space telescopes, the ones that read the comet's chemistry, gathered spectrum after spectrum, watching how its composition shifted as it warmed. An ultraviolet observatory detected the signature of water breaking apart in sunlight, letting scientists estimate how much water the comet was losing, even though water was only a minor part of its makeup. An infrared survey telescope measured its heat, and tried to pin down the size of the hidden nucleus beneath all that obscuring gas and dust. And a European spacecraft on its long journey toward the planet Jupiter and its icy moons turned to catch the comet shortly after it rounded the Sun, adding its own view to the growing collection. From Mars, from solar orbit, from points scattered across the solar system, the machines of a single curious species coordinated to watch a visitor that none of them had been designed to study, simply because it was there, and because the chance would never come again. There is something quietly magnificent in that picture. A civilization that, only a few generations ago, could not leave the surface of its own planet, had by now placed enough robotic eyes throughout its solar system that when a once-in-many-lifetimes visitor passed by in a spot Earth could not see, it could simply ask its scattered fleet to look instead. We have built ourselves a distributed nervous system across the planets, a web of instruments that lets us see around the sun itself. The comet hid behind the star, and we looked at it anyway, from the side, from a robot circling Mars, from a probe sailing toward Jupiter. The ancient traveller could not slip past us even when it tried. It is worth dwelling too on the sheer speed of the encounter, because it underscores how fleeting our chance was. Near perihelion, 3I Atlas was moving at something close to 68 kilometers per second relative to the Sun. To give that number a body, consider the fastest object human beings have ever built, a probe sent to skim the outer atmosphere of the Sun itself, which at its swiftest reached nearly 3 times that speed during its closest solar dives. The comet was not as fast as our fastest machine, but it was moving entirely on its own, unpowered, carried only by gravity and the momentum it had brought from interstellar space. It did not fire an engine, it did not steer, it simply fell faster than any natural visitor we had ever clocked, around the Sun and back out, on a trajectory fixed billions of years ago by the geometry of its launch from a dead star system. We could only watch it go, scrambling to gather every photon before the window slammed shut, and then perihelion passed. The comet rounded the Sun, reached its closest point, and began the long climb back outward, the Sun's gravity now bending its path and flinging it off toward the constellation Gemini and the open dark beyond. It had survived the most dangerous part of any comet's journey, the searing approach to the star, where the heat and the tides can tear a fragile icy body apart. Many comets do not survive their first close pass by the Sun. They crack, they crumble, they disintegrate into a fading cloud of debris and are never seen whole again. The question, as 3I Atlas emerged from behind the Sun and climbed back into view, was whether it had held together at all. Whether this ancient relic, after billions of years of patient travel, had been destroyed in the final stretch, undone by the very star it had come so far to meet. The answer, when it came, was not only that it survived, it was that the comet, on its way out, did something that surprised even the people who had been watching it most closely. Part 10. It survived. And it changed. When 3I Atlas emerged from the far side of the Sun and climbed back into the view of Earth telescopes, the first relief was simply that it was still there. Still whole, still a single coherent object trailing its cloud of gas, not the scattered wreckage that a less sturdy comet might have become. After billions of years in the deep freeze and a searing pass by a star, the ancient traveller had held together, but it had not come through unchanged. As astronomers studied it on its outbound journey, they realized the comet was behaving differently than it had on the way in. It had brightened, it had flared. It was, in a way that caught everyone's attention, more active leaving the Sun than it had been approaching it. A spacecraft watched it flare up as it exited the solar system, a surge in brightness as fresh material poured off the warmed nucleus. New studies found the comet was, in the words of one report, bursting with methanol, releasing that simple alcohol in quantities that had not been obvious before. The chemistry of the coma had shifted, the proportions of the gases pouring off it changing as different ices, buried at different depths, reached the temperatures at which they vaporized. The pass by the Sun had cracked open the comet's behavior, peeled back a layer, let us watch a frozen relic from the dawn of the galaxy come alive in real time, venting materials that had been locked away since before the Earth existed. One headline described it as a startling transformation. The object that had arrived as a quiet grey smudge near Jupiter left as something visibly, measurably altered, awakened by its brush with our star. This is the part of a comet's life that connects it, across all the strangeness, back to the comets we know. Every comet that approaches the Sun goes through a version of this awakening. The ice is warm, the gases vent, the activity rises and falls as the object responds to the changing heat. What made 3I Atlas extraordinary was not that it did this, but that we got to watch an interstellar object do it. An object whose ices had been assembled around a different star, in a different era, and had never once been warmed in all the billions of years of its journey until the moment our Sun reached out and touched it. The methanol burst, the brightening, the shifting chemistry, these were the first stirrings of an ancient thing waking from the longest sleep imaginable, and then, almost immediately falling back towards sleep again as it raced away from the warmth and back into the cold. Because that is the bittersweet truth of the encounter. The awakening was also a farewell. Every gram of material the comet vented near the sun was a gram it would never get back, lost forever to space, a small permanent diminishment of an object that had endured nearly intact for the age of the galaxy. The sun gave us our one good look at 3I Atlas by warming it into activity, and in doing so it began, gently, to consume it. The comet that leaves is slightly less than the comet that arrived. It will not pass another star for an unimaginably long time, if ever, and so this brief flaring, this single burst of methanol and gas and light may be the only time in the entire history of the universe that this particular object ever came alive. It woke once for us, and then it went dark again, carrying the rest of its ancient self back out into the night. And as it climbed away, the telescopes kept watching for as long as they could. New images came in through the following months. The comet shrinking, fading, sliding outward toward Gemini, still trailing its diminished coma, still giving up the last of its readily observable secrets. Astronomers raced to publish, to capture every measurement before the object dimmed beyond the reach of even the largest instruments. There was a sense, in the flood of papers and images, of a community trying to hold on to something it knew it was losing, gathering every last photon from a visitor that would, within a year or two, become too faint and too distant to study at all, and then, eventually, impossible to see by any means we possess. It is strange to grieve an object, but there is a real and human poignancy in the outbound journey of 3I Atlas, and it is worth letting yourself feel it as you drift towards sleep. For billions of years it fell through the dark, untouched, unseen, unknown. For a few months it passed through the light of our sun, and during those months a species on a small blue planet pointed every instrument it had at the visitor and learned its age, its origin, its chemistry, its strangeness. We gave it a name, we argued about what it was, we watched it round the sun and flare and transform, and then it left, and it will keep leaving, falling outward forever, slipping back into the same darkness it came from, and it will never know that for one brief season it was the most watched, most discussed, most wondered about object in the sky of a world it passed in silence. There was even, for the boldest among us, a question of whether we could chase it, whether some future mission launched with enough speed might catch up to an interstellar object on its way out and travel alongside it, studying it for years instead of months. The proposals exist, daring plans to intercept the next such visitor, and some looked at 3I Atlas and dreamed of pursuit. But the comet's tremendous speed and its single unrepeatable path made any real chase, for this particular object, all but impossible. We had no craft ready, no rocket fast enough, no time to build one before the window closed. So we did the only thing we could. We watched it go, and we turned our minds toward the future, toward the ones we have not yet seen, the next ancient stranger that will someday fall in from the dark while we are perhaps finally ready to meet it. For 3I Atlas will not return. That is the one thing about it that is absolutely certain, the one fact with no caveat and no uncertainty. Its path is open, its speed is unstoppable, its course is set. It is leaving, and it will keep leaving, and no human being now alive or yet to be born will ever see it again. Which raises the last and quietest question of the whole story. If this is only the third such visitor we have ever caught, in only a few short years of being able to catch them at all, then how many others have come and gone unseen? How much silent traffic moves through our solar system in the dark? And the answer to that, when you sit with it, is the strangest and most beautiful part of all. Part 11, The Silent Traffic in the Dark, 3. In all of human history, in all the centuries of watching the sky, we have caught exactly 3 objects in the act of passing through our solar system from beyond it. The first in 2017, the second in 2019, and now 3I Atlas. The third, the oldest, the strangest. 3 confirmed visitors from the deep. And here is the detail that should change the way you picture the night sky forever. We only found these 3 because we recently built telescopes good enough to find them. We did not find the first one until 2017, not because the first one only arrived in 2017, but because 2017 was roughly when our sky surveys finally became sensitive enough and fast enough to notice such a thing slipping through. Before that, we were effectively blind. The visitors were almost certainly coming all along. We simply could not see them. So how many are there? The astronomers who study this question have worked backward from the discoveries. If we found objects this size with these survey telescopes at this rate, over this span of years, then the math implies a certain density of such objects drifting through interstellar space. And the numbers that fall out are quietly astonishing. The estimates suggest that an interstellar object roughly the size of 3 Arcturus, large enough for us to detect, passes through the inner part of our solar system on the order of once every 5 to 10 years. That is just the large ones, the ones big enough to catch with current technology. The smaller ones, the boulders and the gravel and the dust of other star systems, must be vastly more numerous, passing through constantly, an invisible rain of foreign material sifting silently through our neighbourhood all the time, far too small and faint for us to ever notice. Think about what that means. At this very moment, as you lie here, there are almost certainly pieces of other solar systems inside our own. Fragments thrown out of distant star systems drifting through the space between the planets, passing the sun and moving on, completely undetected. The dark between the worlds is not empty. It is busy. It is full of traffic, a constant slow migration of debris from every star that ever formed planets and flung away its leftovers. Each star a fountain, spraying icy fragments into the galaxy over billions of years, and all those fragments mingling in the vast space between the stars, some of them inevitably drifting through here, through our solar system, past our sun, while we sleep, while we work, while we live our entire lives unaware. We caught 3. We missed, almost certainly, thousands upon thousands of others. They came through unseen, in the centuries before we could look, and they are coming through still, the small ones invisible even now, a silent procession of strangers we will never name. And we're about to get much better at seeing them. New observatories are coming online, telescopes far more powerful and far faster at scanning the whole sky than anything we have had before. Instruments designed precisely to catch faint moving objects against the crowded background of stars. With them, astronomers expect the trickle of interstellar discoveries to become a stream. Where we once waited years between visitors, we may soon find them regularly, several a year, perhaps more. Each one a new sample from a different star. Each one a new recipe, a new age, a new origin, a new piece of a distant world delivered to our doorstep for free. We are right now at the very beginning of a new kind of exploration, one where we do not have to travel to other star systems to study their material, because their material comes to us, falling in from the dark, if only we are patient and watchful enough to catch it. 3. iAtlas, then, is not an ending but an opening. It is the 3rd visitor, but it will not be the last. It is the oldest we have found, but somewhere out in the dark there are surely older ones still, fragments closer yet to the birth of the galaxy, waiting to drift through while we watch. It is the strangest we have measured, but only because we have measured so few, and each new one will redraw the boundaries of what counts as strange. The story of 3i Atlas is really the story of a species learning, for the first time, that it lives not in a sealed and private solar system, but in an open one, a way station on the great highway of the galaxy, visited constantly by travellers from everywhere, most of them slipping past in silence, a few of them now, finally being seen. And where is 3i Atlas now, as you lie here in the dark? It is out beyond the orbits of the planets, climbing away from the sun, fading, falling outward toward the constellation Gemini and the open galaxy beyond. It is colder by the day, its brief awakening already behind it, its coma thinning, settling back toward the frozen stillness it knew for billions